Welcome back to another video, guys, and in this video we will cover the bracketing methods when it comes to numerical methods. So there are the bracketing methods and the open methods. In this video we'll cover bracketing methods. Basically it's used to solve non-linear equation. Okay, any like complex non-linear equation it can solve. There are three methods. The two most important ones are bisection and false position. Graphical is not that important, but we'll cover it either way really quickly. And in the next video, hopefully we'll do open methods. So in this video, we're gonna focus on bracketing methods. Right. So when it comes to graphical, it's quite straightforward. It's just when it intercepts the x, that's the root. Okay, that's all you need to know. It's not that hard. It's not that complicated. Now let's get into the bracketing methods, the proper bracketing methods. So the first thing you have is the bisection method, right? So you have a lower bound and you have an upper bound. So you have an interval, right? Fxl and Fxu, if both of them are positive, that means there is either no roots or there are even number of roots, as you can see, right? Because if it's positive, there could be no roots, and if there are some roots, it's going to be an even number of roots. Okay. Similarly, if it's positive and it's negative, if Fxl is positive and Fxu is negative, then odd number of roots are present. Okay, so these are the couple of examples. Here you go. So now we're going to look into the bisection method, the proper. So the main formula for the bisection method is xr, which is the estimate root, equals xl plus xu over 2. So it's basically the midpoint between the lower and the upper bound. Okay, that's how it approximates the root. One thing you have to keep in mind in this method is fxl multiplied by fxr. If it's less than 0, then for the next iteration you have to basically, if it's less than 0, then we take the lower interval. Okay, then that means the root is in the lower interval. If it's greater than 0, that means it's in the upper interval, and if you hit equal 0, that means you found the root. Okay, that's how it's done. So let's do an example. So assume xl equals 12 and xu equals 16. So you have 12 and 16. So 12 is the lower bound and 16 is the upper bound. Okay, fxl is 6.067 and fxu is minus 2.269. okay, so that means there is definitely a root in between. So you put this into the equation, you estimate the root, and you get 14. Remember, it's the midpoint. For bisection we always take the midpoint. So you do fxl multiplied by fxr, which are these two values, and it's positive multiplied by positive, so it's going to give you a positive number. That means the root is in the upper half of the interval, 14 to 16, and as you can see, the root is here. Okay, so there's no root here because there's no intersection with the x-axis here yet. The root is here, so it's in the upper interval, 14 to 16. Then so now we assume the new interval is 14 to 16. That's the lower bound now, so it becomes 14 to 16 like this. Okay, and then you do another iteration. So now the midpoint is 15. You do fxl multiplied by fxr, and then the root, basically the root falls between 14 and 15 because you get a negative number. Okay, and you keep doing this until you go below a certain stopping criteria. Now the recommended stopping criteria could be 0.05%, but in this case we use 0.5%. and as you can see, we start from an initial guess of 12 and 16 as the bounds, the upper and lower bound, and we basically go down to these two bounds and finally get the root at 14.813 with a error of 0.422, which is less than 0.5. so we stop, and this is your root. Okay, so this is one of the methods. You can use bisection methods to solve these sort of problems. Now when it comes, this is basically the format of how you would solve the bisection method. So imagine you have like a nonlinear equation such as this is a polynomial for order 5, and then you had to basically find the root. So this is how you do it, and this is the root. Okay, this is how it's done. Now let's go into the false position method. A shortcoming to the bisection method is that in dividing the interval xl to xu into equal halves, remember we take the midpoint, no account is taken of the magnitudes of fxl and fxu. For example, if fxl is closer to 0 than fxu, then it is more likely that the root will be closer to fxl. So basically what it's trying to say is, if you see over here, the root was here, yeah, but the estimate is always in the middle. It's always in the middle, and that can be a problem because that would mean the computer would need to do more computations to reach the root. Okay, so another efficient way is to use this equation, a modified equation, okay, which basically modifies the slope and gives you a better estimate of the root. So if you look here, it's the same concept, just the formula is replaced. Okay, this is the updated new formula. XR equals XU minus this whole stuff. That's the new formula. Okay, we will use that in this example. So similar thing, 12, 16. Remember the first iteration for bisection, the first iteration we got 14. The first iteration over here we got 14.9113. Which one's better? Obviously this, right? This is better because in the first iteration it's giving a better estimate because of the improved formula. So remember, is the same procedure, just use this formula. Okay, and you keep basically going up and down the interval, up and down, and you end up with 14.742, and this is the procedure. And as you can see, its first estimate of the root, which is XR, is much better than the bisection, because for bisection we got 14 and for false position we got 14.91131, which shows that the false position is more efficient when it comes to finding roots for nonlinear equations. However, there are certain cases where the false position performs like it's less efficient than the bisection method. So in this case specifically, you can solve this problem. Okay, this is a problem that you can solve, and as you can see in the fifth iteration you get 4% error over here, and here you get 17.1%. so sometimes there can be errors. There are certain situations, but generally speaking, false position is a better method than bisection. These are the answers to this question. So if you want to try it, you can try it yourself. This is the format. Do it like this. Construct a table, put all of these things inside, and keep tracking the error. Once it goes below a specific stopping criteria, then stop your iteration, and XR is the root. Okay, false position is the same method. You do the same thing and then you stop at a specific percentage, error percentage, stopping criteria, and that becomes your root. Okay, that's how it's done. Next video we'll do open methods. Thank you for watching, and I hope you understood this method really well. And one other thing I forgot to mention was, if you go click on the link in the description, you go to Fiverr. Okay, and yeah, just go and you can hire all these guys. I don't think I mentioned that. So yeah, you can click link in the description and hire all these guys. Thank you. Bye bye.